Hello, anybody answer?
Yes, sir.
Yes, sir.
Okay, okay. കഴിഞ്ഞ പ്രാവശ്യം ഇങ്ങനെ സംഭവിച്ചു. സ്ലൈഡ് പ്രസന്റേഷൻ മോഡിൽ പോവാതെ നമുക്ക് ക്ലാസ് എടുക്കുന്നതായിട്ടുള്ള വീഡിയോയിലോട്ട് പോകാം. ഓക്കെ. So now we'll go through the Fourier transform. So even though this is a review or a revision for you. So suppose we have two signal. One is periodic and another one is a periodic one. If the signal is periodic nature, we go for the Fourier series transformations. And if the signal is periodic nature, we have to take the Fourier transform. And why we go for this Fourier series and Fourier transform, we have to know what is the frequency content or what is the spectrum of the signal. Okay, so if the signal is aperiodic, the frequency spectrum is continuous. That is another property. Even though we go for the signal is aperiodic, we take Fourier transform, and so that we obtain the frequency spectrum of the signal. That frequency spectrum is a continuous in nature. That is a property. Okay. Thus, the frequency spectrum will be a continuous function. So I will repeat once again. If the signal is a periodic nature, and if you are taking the Fourier transform, the spectrum is in continuous time. Okay. So suppose we take as a signal like this, just an arbitrary signal having a periodicity from minus t1 to t. Let's say that it is an aperiodic signal because there is no periodic nature of the periodic nature of it. You can see it. You can see it is not a periodic one. So next, so we take as the same signal we can treat as a periodic nature by say that the repetition of the same signal is called S tilde of t. So same signal, a periodic signal, we can consider as a periodic signal, X tilde. So same signal is having minus t1 to t up to t1. The same one is repeating in the right hand side as well as left hand side. So now S tilde t is considered as a periodic nature. Okay. So now it is a periodic one. So if the signal is periodic, then we can say that we can apply the Fourier series property of Fourier. We can apply Fourier series transform. So that means X tilde t, it is equal to summation of ak e raised to jk omega t. The tilde t, we can represent that in terms of the summation of exponential sequence. Okay. Where, so this is a Fourier series expansion where ak means the coefficient of this Fourier series. Ak is equal to 1 by t into integral minus infinity to infinity s tilde t e raised to minus jk omega t dt. Okay. Where you can consider as it can be tends to infinity. xt you can consider as the s of t, where that is we have a signal like S of t, that signal we can treat as a periodic property, say that that signal is an S tilde t. So that if you are applying the xj omega, which is equal to x integral of minus infinity, that is a Fourier transform of integral of minus infinity to plus infinity, x tilde t e raised to minus j k omega 0 dt. So from this expression, we can say that x capital X j omega, which is equal to integral of minus infinity to infinity delta t e raised to minus j omega t dt. So this equation is known as the Fourier transform equation. So if we have a periodic signal of x of t, we can represent, we can take the frequency spectrum xj omega by taking the integral of minus infinity to infinity x of t into e raised to minus j omega t dt. So this is called Fourier transform equation, very popular tool in signal processing. So in the Fourier transform, so similarly we can find the inverse Fourier transform. That means x of t is equal to 1 by 2 pi integral of minus infinity to plus infinity x j omega e raised to j omega t d omega is called the inverse Fourier transform. That means we can convert the xj omega, we can convert from xj omega to x of t. The original signal we can collect it from the frequency domain by applying the inverse Fourier transform equations. Okay. So these are the two basic equations. First is Fourier transform equation, xj omega is equal to minus integral of minus infinity to plus infinity x of t e raised to minus j omega t dt. And this is obtaining the Fourier transform, or we can say that it is a frequency spectrum of the signal. So if we know if we want to find the frequency spectrum, we can just apply the Fourier transform where x of t is an aperiodic nature. So similarly, the original signal can be obtained from the xj omega by taking the inverse Fourier transform. So, okay. So next slide. The magnitude and phase representation of the Fourier transform. So how you find the magnitude response and phase response of a Fourier transform. So even though xj omega is a complex function, can be represented in terms of real time and imaginary term. So xj omega can be equal to x r j omega plus imaginary j into x1 xi j omega. So real plus imaginary thing. Because of xj omega is a complex function, we can that signal can be represented in terms of real and imaginary part. So that the magnitude of xj omega is equal to xj omega magnitude is real part square plus imaginary part square root of. So root of real part square plus imaginary part square can get the magnitude of xj omega. Similarly, in the phase response, the angle of xj omega, which is equal to tan inverse imaginary part by real part. Imaginary part by real part. Okay. So this is the even though we obtain the spectrum, from this spectrum we can find what is the magnitude of the spectrum and what is the phase of the spectrum. So magnitude is just to root of real part square plus imaginary part square, and phase part is tan inverse imaginary part divided by real part. That is xi j omega by xr j omega. Okay. The next famous very important condition is the condition for the convergence of Fourier transform. Suppose the Fourier transform x j omega which is equal to integral of minus infinity to plus infinity x of t e raised to minus j omega t dt. So just to take the Fourier transform. Suppose if x of t is convergent, then integral of infinity to plus infinity, the modulus of x of dt should be convergent. If and only, that is if x of t is convergent, if and only some of the conditions mentioned. So one condition is if it is convergent, x of t is absolutely integrable. The modulus of x of t should be less than that of infinity. So absolutely integrable, and has only the finite number of maxima and minima in any finite interval. There's a finite number of maxima and minima in any finite interval. That means its maximum and minima can be countable. Finite numbers means countable. It is not infinite. And another condition is has only finite number of discontinuity in any finite interval. So these are three conditions. If it is converged, then it is x of t is integrable, then maxima and minima should be finite, and it has a finite number of discontinuity, so that the x of t is convergent. So if this condition is satisfied, it converges to the all point of continuity. Okay, so this is called Dirichlet conditions for convergence of Fourier transforms. I think these are very basic problem. Find the problem. Find xj omega for a signal having x of t is equal to delta t. Actually, it is a find the Fourier transform of x of t, where x of t is delta t. So just to write the basic equation, xj omega is equal to integral of minus infinity to plus infinity x of t into e raised to minus j omega t dt. Where again substitute, delta t is, it is the 1. So e raised to j omega t, where t is equal to 0, which is same as 1. So that is equal to xj omega. So from xj omega we can calculate. So we have obtained x of t. So we are xj omega is 1, and magnitude response is xj omega modulus of xj omega. That means to take the what is the magnitude of this one. So magnitude of this one means root of real square plus imaginary square. Okay, so here only real part. So this is same one. So 1 etc. So that is why the magnitude is a straight line. But whatever the change in the frequency, you can feel this. Whatever the change in the frequency, the magnitude is constant. And what happened to the imaginary or phase response? Phase response is equal to tan inverse imaginary part divided by real part. So what is a imaginary part? Imaginary part is 0. So 0 by 1. So 0 by 1 is tan 0. Tan 0 is 0. That is why angle of xj omega is a 0, 1. So it will not have any angle. What are the changes in the xj omega? There is angle is 0 itself. So this is a simple example of how to find magnitude response and frequency response. So saying one more example, one more example. So find x of j of for an e raised to minus 8t u of t. X of t is equal to e raised to minus 8t u of t. So before we applying the equation, so we can feel what is the uh, property of, what is the peculiarity of the signal. So it is e raised to 80. E raised to 80 is an exponential signal. Its value is depending on the value of a. Okay. So value, if a is less than 1, it is having some values. And if a is greater than 1, having some value. That is depending on the value of a or function of a into u of t. U of t is a right hand side sequence. So when you apply in the signal with u of t, the signal itself is a right hand side. So that means x of t is a only right hand side signal. Means it has a value starting from 0 to right side up to infinity, and there is no values in the and t is equal to negative. Okay. So just then apply the Fourier transform xj omega, which is equal to the basic equation integral of minus infinity to plus infinity, integral of minus infinity to plus infinity e raised to minus j omega dt. Just to apply x of t in terms of uh, e raised to minus 80, so that when you applying u of t, you can apply u of t. Now the limits, the next step, the limits is changing. So 0 to infinity, because it is only right handed side sequence. So e raised to minus 80 into e raised to minus j omega t. So that just to integrate e raised to e raised to minus of a plus j omega t by when you integrating this minus into a plus j omega, and limit is from 0 to infinity. Okay. When you are applying the uh, infinity, so just t is equal to infinity, and whatever happened is the uh, 0. So when you t is equal to 0, so it will be 1 by 1 minus of 1 by minus of minus plus 1 by a plus j omega. So this is x j omega, right? Frequency transform, and the magnitude function xj omega we can obtain by taking the root of real part by imaginary. Uh, if it is having numerator and denominator, you take root of the numerator part of real part and imaginary part, and divide by root of real part square by plus imaginary part square in the denominator. So you can calculate the this magnitude of numerator as well as denominator in separately. So here our equation or result is only having denominator part, so it is equal to 1 by root of real part square plus imaginary square. So imaginary part is j omega, so it is omega, that is why it is omega square, so which is equal to magnitude square. So if a signal having minus series to 80, suppose having the value is it is only having the values in the right hand side, and its magnitude, when you draw the magnitude, then you substitute omega is equal to different values. First two, we can obtain the omega is equal to 0. 0 part is, this part is 0. So that it is having only value 1 by root of a square. So it is equal to 1 by a. So that is why omega having the values of e raised to 1 by a. Then when you adding omega different values, will be uh, slowly or monotonously decreasing up to infinity. So, the similar to, even though it is a modulus of this one, whatever happening in the right hand side having the same values in the left hand side. That is why it having a mirror image of the right hand side. So when you have a 0 here, the graph is like this. Similarly, there is a same graph is like this because we are taking the modulus. So that means modulus can be a result of minus s plus a. And what happened to the phase response? Phase is angle of xj omega, which is equal to minus of tan. Minus means when you take a denominator. If it is a numerator part, tan inverse imaginary by real minus tan inverse of uh, imaginary by real in the denominator part. That is why you are having minus of tan inverse omega. Omega means imaginary part. That's imaginary part by real part. Minus tan inverse omega. So now also we can apply uh, 0, 0 tan was 0. So means it is 0 here. And if it is tan was infinity, can be either minus pi by 2 or plus pi by 2. So that is why this graph is like this. Okay. So this is the response. So this is a signal and this is a magnitude response at frequency terms, or the phase response. Okay, next. So this is the overall detailed graph of the uh, previous problem. So this is a e raised to minus 80. So it has a values only in the right hand side. So left hand side is 0 because we are multiplying with u of t. Then magnitude response is like this. The max omega is 0, it is 1 by a, and omega higher values of omega is decreasing. And lower values of omega also is decreasing. Okay. So next problem. Suppose x of t equals e raised to minus a modulus of t. E raised to minus a modulus of t. So same equation we can represent it as two ways. E raised to, when you lifting this modulus, e raised to minus a minus of t, as well as e raised to minus a plus t. So when you have a modulus, the t has having the values, we have to consider having the values. Either it is negative as well as positive. If it is negative, it is e raised to 80, where t is equal to less than 0, and e raised to minus 80 when t is greater than 0. Two conditions. One is positive and other is negative. So the same signal having the t having some values, c is less than 0 having values this, and t is greater than having the values e raised to minus 80. So now we are applying the equation for finding Fourier transform. Xj omega is equal to minus j omega d raised to minus infinity to plus infinity x of t e raised to minus j omega t dt. So just to replace x of t in terms of 2 time, because we can consider from t is less than 0 e raised to 80. That is why it is minus infinity to 0 e raised to 80 into e raised to minus j omega t dt, plus in positive side or right hand side sequence it is equal to 0 to infinity e raised to minus 80 into e raised to minus j omega t. So we can same signal we can consider depending on the range. You can consider the two signal. So we can integrating separately, so that we'll having the value from minus infinity to 0, and another one is having the value from 0 to infinity. So first is 1 by 1 minus j omega plus 1 by 1 plus a plus j omega. So that overalls will be 2a into 2a by a square plus j omega square. This is equal to xj omega, or frequency response. Frequency response. So this is an original signal x of t. X of t is equal to having the value right hand side is decreasing and left side it is raised to 80, and like that. When you this, finding the modulus of xj omega, which is equal to, you just to find the what is the all time is so taking the magnitude, so denominator you can take 2a itself, and numerator is also it is equal to a square plus omega square, because there is no imaginary part, so that so when you taking the magnitude, the same values can be obtained. And when you are substituting omega is equal to 0, so, so omega 0, this term is 0, so it is 2a by a square, so which is equal to 2 by a. That is why at omega 0 it is equal to 2 by a. And when you're having higher values, it is decreasing, and lower values also decreasing. And this phase spectrum is equal to 0, same one, because it is a real time. So naturally, tan was 0 is 0. So having the value 0. So this is a magnitude response and phase response. So one more problem regarding this magnitude response. Find xj omega 4. Find xj omega 4 a signal for a signal x of t is equal to 1 for t is less than or equal to t1, and 0 for modulus of t is greater than or equal to t1. So it is when t is equal to having the values both side, means either minus t1 and plus t1, it is value is 1. So that is why from minus t1 to plus t1 it is 1, and if t is greater than, then it's having greater than minus t1 and less than minus t1 will having the value 0. So actually this signal is nothing but it is a rectangular signal having value from minus t1 to t1. Okay. So just to write the basic equation, so where you can consider only from minus t1 to t1, 1 into e raised to minus j omega t. So just to integrate e raised to minus j omega t, integration, when you're taking integration is equal to minus j omega. To integrate from minus t1 to t1, so that again having the expression of e raised to minus j omega t1 minus e raised to plus j omega t1 by minus j omega. So this is nothing but it is a what sine. The 2 into sine omega t1 by omega. Because e raised to minus theta minus e raised to plus theta by 2j is the sine theta. So here there is by 2 is not here, so we multiply 2 into sine omega t1 by omega. Okay. Then this can be convert to a sinc function. So the same one we can convert to 2t1 into sine 2 pi ft1 by 2 pi ft1. So this term is equal to a sinc term 2t1 into sinc of this one. So actually this signal is nothing but can be also be expressed 2 sine 2t1 into sinc of 2ft1. So sinc is like this. It is right hand side. It is oscillating but decaying. It is oscillating but decaying. Decaying means the value is decreasing. The left side also is oscillating towards left but is decaying. So this is a sinc function, or it is equal to uh, xj omega. Xj omega, or we can take it, this is a magnitude or function of the signal. Magnitude. So both the same one. Next is also same function, because just only this is x of t. So here x of t, the signal is a rectangular signal, and the Fourier transform is a sinc function. The next signal is, suppose we take as a Fourier transform is a rectangular function. Suppose 1, which is modulus of omega is less than of capital W, and 0, modulus of omega is greater than W. So here it is, the Fourier transform is a rectangular form. So we can check what happened to the x of t. So x of t is basic equation, inverse Fourier transform equation is this. X of t is equal to 1 by 2 pi integral of minus infinity to plus infinity xj omega into e raised to j omega t. E raised to, it is not e raised to minus j omega t, it is just e raised to j omega t d omega. And just applying the x e raised to j omega for a limit from minus w to plus w, so minus w integral of the minus w to plus w 1 into e raised to j omega t. So we can take a same function e raised to j wt minus e raised to minus j wt by j2 pi t. So this is equal to w by pi into sinc of wt by pi. So x of t is this, again it is a sinc function. Sinc function. Okay. So that means from these two problem, you can familiarization is, if the signal having, if x of t is rectangle function, the Fourier transform is continuous, and this is sinc function. And suppose if the Fourier transform is a rectangle function, the x of t is a, again it is a sinc function. Okay. Up to this, Okay, any doubt? Any doubt regarding? Just to go through the what is the magnitude response and phase response of a Fourier transform or a signal. What is the magnitude response and phase response of a signal? Signal having a periodic nature. Can go to